Sorry, I accidentally stopped that video before it was done. So we'll just finish up with a new video. This one, if we plug it in, we get approximately 2.9. So if sigma is 0.9 and mu is 7, meaning the mean is 7 and the standard deviation is 0.9, then a data value of 9.6 is approximately 2.9 standard deviations above the mean. We can use this formula to solve for the data value or the mean or the standard deviation if we know the other values. So this example says find the data value if z is 0.4, mu is equal to 10, and sigma is equal to 2. So I want to find x in this case. Remember, our formula looks like this: z equals x minus mu over sigma. And in this case, z is 0.4, x is what I'm solving for, mu is 10, and sigma is 2. Now, hopefully you remember from the fractions section we looked at earlier, if I multiply fractions, I multiply across, but I can do some cross-canceling if possible. So what I want to do is get rid of this 2 in the denominator. I'm going to do what's called clearing the denominators and multiply both sides by 2 over 1. I'm allowed to do this because I multiplied an equation by the same thing on both sides, so the equation is still balanced. And now what happens, this 2 will cancel with the 2 in the denominator, so that fraction is gone. That gives me 0.8 is equal to x minus 10, and then I add 10 to both sides, and 10.8 is equal to my data value. Okay. The big thing here is multiplying both sides by the denominator so that the denominator will go away and we don't have a fraction anymore. Our last example says find the mean if z is equal to negative 1.8, x is equal to 100, and sigma is equal to 5. So in this case, I want to find the mean of the data set. Again, I have that same formula. Now z is equal to negative 1.8, x was equal to 100, mu is what I'm solving for, and sigma is equal to 5. Again, just like on the last one, I'm going to multiply both sides by that denominator so that I don't have a denominator to deal with anymore. And I like to multiply by 5 over 1 so I can tell what's in the numerator and what's in the denominator. Oops, this is a 1, if you can't tell. It's just a little trick that I use. So those get canceled out, and I end up with negative 9 is equal to 100 minus mu, because negative 1.8 times 5 is equal to negative 9. Now what I'm going to do is subtract 100 from both sides. So negative 109 is equal to negative mu. And now you can multiply or divide by negative 1 on both sides. And 109 is equal to mu. So the mean is 109 if a data value of 100 gives us a z-score of negative 1.8.